Welcome to another special episode of Science Nights. Today we are discussing the Cassini grand finale. So
Yeah.
if you don't know what Cassini is, it's a space probe that has been exploring the Saturn system since, since July 1st, 2004, when it became the first spacecraft to orbit Saturn.
13 years?
Yeah. It was originally just going to be like a 4-year-long mission, and they kept extending it.
So Friday, September 15th, is a milestone on two marks. Cassini's going to dive into the middle of Saturn, and I'll have gone 30 times around the sun. So they're both monumental occasions.
So I figured we kind of just real quick go over a little bit about Cassini. It was an unmanned robotic spacecraft. It was a collaboration between NASA, ESA, so the European Space Agency, and ISA, the Italian Space Agency. I believe it cost
It cost a lot of moolah.
Yeah, in the end,
$3.26 billion.
Yeah, quite a bit.
Yeah, it's a lot of money. That's across 3 nations too. Well, the European Union's a huge thing, so it's across 2 continents.
Right. Before launch, I think there was 17 nations all working together.
Right on.
As of now, I think the NASA site said its total is like 27 or something.
Billion.
So 27 different nations working, or at least scientists, right? Scientists and engineers from
Gotcha.
all those different nations.
Right on. So it's actually called the Cassini-Huygens mission, and that's Huygens, Huygen.
Huygens, because apparently that's the best we can pronounce it since we're not Dutch.
Yeah.
And we can't go like, ha.
Well, you just did. I mean.
Yeah, I doubt I did that right, though.
And I guess I didn't know this, but the Cassini mission is 2 parts. There's one for Saturn, and then there's one for a lander going to Titan. I didn't know about the Titan lander.
Yeah, so it was the farthest landing we've ever made on a body. Still today, I believe. So
Titan's a moon of Saturn.
yes, yeah. Titan's was one of the first discovered moons of Saturn. So it was Christian-Huygens that actually discovered Titan
In 1655.
Yeah, and that's why it's named after him.
Yeah, of course, yeah.
And then Cassini was named after Giovanni Cassini, who also discovered the next 4 moons of Saturn.
Yeah.
And also noted the division in the rings, because before then we couldn't really tell.
We all just thought it was one ring.
Yeah.
To rule them all.
And so now that division is called the Cassini division.
Right on. It's also interesting to note that Cassini is the 4th spacecraft to visit Saturn or go past it. There was Pioneer 11 in 79, Voyager 1 and 2 in 80 and 81.
Yeah. Yeah, so much we've learned from the Voyagers.
Oh, yeah.
They were kind of like the prelude to this mission, you know?
I was hoping you were going to say Pioneer, and I was like, it's not a Pioneer.
But NASA definitely took stuff that they learned from those missions to for the Cassini-Huygens mission.
Yeah. Well, I mean, one of those things that you can definitely talk about is the number of flybys that they used to get it to Saturn. Cassini had to use gravity assists around Venus twice and Earth once and then Jupiter once.
Yeah.
It's crazy.
Just to get it up to speed to get out to Saturn.
Mm-hmm.
Otherwise, it would just come back. Yeah. Was a bit of a rough start getting it launched. There was another mission that was supposed to launch with it, but it ended up getting canceled. And there was some changes going on in NASA administration. They were trying to get more efficient missions, you know. And this one was considered like a flagship mission. It was very expensive.
Yeah.
And had all of the scientific equipment they could stick on it. But it ended up staying, and luckily it
launched on October 15th, 1997. That's interesting. It launched on October 15th, and it's terminated September 15th. 20-year mission, almost 20 years to the day. Interesting. And just it's very interesting.
It took Cassini 7 years to get to Saturn from Earth.
Yeah. Yeah. And then it was in December, after Cassini had arrived at Saturn, it was in December, right near Christmas of 2004, that Huygens separated from Cassini and landed on Titan. And the separation happened December 23rd. The landing happened on the 13th of January. The descent lasted 2.5 hours, and the batteries on the probe lasted for 72 minutes on the surface.
Yeah.
2.5 hours, like, so, whatever, 13 days worth of travel.
Right.
And then 2.5 hour descent, 72 minutes of battery life, and then that's it.
Yeah. We did get a lot of data from that, and that's where they learned about a lot of the lakes of hydrocarbons on the surface of Titan. So methane, ethane, you know. And we got some pretty interesting pictures from the surface, too. It's a very,
Never seen pictures of Titan.
rocky world. There'll probably be one somewhere around
Yeah,
here.
I feel
It'll probably be over there, actually. But,
Yeah.
you know.
Just cover this.
Yeah.
There's a ton of interesting things that happened. From the creation to the launch and landing of Huygens and the orbiting of Cassini. We didn't start talking about it until last year on Waiting for Players, and maybe it was this year, and we didn't actually start seeing any of the cool pictures from it until this year. For instance, one of the ones that I'm thinking of from Cassini is the hexagonal storm that's at the North Pole of Saturn.
Yes.
That
Yeah.
is weird because normally nature doesn't have sided shapes.
Right, when
They
you
have
think of
rounded
like
elliptical
fluids
shapes or whatever.
moving and stuff, you think of like a spiral in
In a circle.
Right.
But on Saturn, there's a like it's got angles and stuff.
Yeah.
On it. And they're rough, they're rounded, but like they're not perfectly drawn. Adam's gonna show you the picture.
Yeah.
But it's just interesting that like I've never thought that we'd see that in space. Like even the big red dot on Jupiter is an oval.
Right. Right. And apparently, as far as I understand, it has to do with just like the sheer size and pressure of the fluid moving. That's just something fluid does at that size and pressure.
Let's recreate
I'm
that.
sure. Oh yeah.
I'm looking forward to recreating that.
We need to go really far out somewhere to get enough space.
Like Nevada.
A lot of the ring structure and moons were discovered. There was quite a few moons discovered, actually.
From Cassini?
Around
Saturn?
that we never knew about before because we didn't have anything sensitive enough to look at it until Cassini got there.
I'm pretty sensitive. I could. This is where John's like, yeah, witness.
So I believe the total comes out to like 62 moons now.
Wow.
Natural satellites around Saturn, and one of them is the moon like orbits inside the ring, so it makes the separation in the rings.
Really?
It also creates little ripples along the rings.
That's awesome.
We got a lot of pictures.
So there's a celestial body that like carves a hole in the ring.
The rings are basically like
I know they're miles apart.
well, but they're basically like a breeding ground.
Oh,
So the
okay.
rings
4
are
moons.
are constantly like snow and rock like coalescing and then being torn apart again because of Saturn's
Gravity, yeah. Okay. It's just how like it's always. I mean, for most part, people contextualize Saturn's rings as, oh, it's pretty dust around the rings of Saturn. It's
Right.
oh, look how pretty it is.
Yeah, no. Apparently, it's extremely active and chaotic.
Yeah.
One of the
Makes
most
you
chaotic
wonder-
systems we've seen in the solar system. At
Makes you
least.
wonder about them around Uranus or Neptune. See, like if those are
Yeah,
also doing
for
the
sure.
same thing.
I'm sure when we actually do send things out that way, it'll blow our minds the things that they discover.
Yeah.
So. Kind of an interesting fact, on April 7th, 2004, Cassini took pictures of 2 storms merging together into one larger storm on Saturn.
So it arrived at Saturn July 1st, 2004.
Yeah,
it noticed that it coming up to it.
This was pictures on its way up. I think it started taking pictures like 3 months before or so.
Gotcha.
And then because they actually did a camera test like 2 years before it got to Saturn.
Gotcha.
Just to make sure everything's still working, you know?
Yeah, right. Hello,
Don't want to
Cassini, are
get
you
there and be like,
alive?
oh man, start all over.
That would suck.
Right.
Hey Bob, you know how you came into NASA like when we launched this thing and you were like, oh, it's too expensive. Turns out you were right. Sorry, Bob. NASA administrator's name's Bob, by the way.
I'm sure there probably are some.
There's got
Yeah.
at least one Robert in NASA.
Right.
He's like the janitor.
Saturn's always been one of my personal favorite planets.
Sure,
If I
man.
had
It's
to-
the
if I had to
prettiest.
pick one. I think a lot of people would probably say that too.
Yeah.
So it's awe-inspiring, especially if you've ever seen it through a telescope. It looks a lot different. It looks exactly like the pictures you see, but it looks a lot different than the other systems or the other bodies.
You just imagine looking through the telescope. You see that right there? That's Saturn. Where's the rings? There aren't any. That's just what they tell you there is.
It's flat.
Yeah, right? The Flat Saturn Society. Saturn's always cool because, like, it's probably the most unique of all the planets as far as, like, well, we know that every outer planet has rings now, right?
Yes.
But
Yeah.
these are the ones that are the most visible. Every other planet's just a circle. Like, okay, yeah, Uranus or Neptune is on its side. Woo!
Yeah, right.
It's still a ball. Saturn's like the one that's like got a hula hoop going. And you're like, yeah, work it. Saturn. I'm like channeling John right now, I think is what's going on.
Cassini also discovered that in Enceladus, I almost
The planet?
Enceladus is another
it's
one
a
of the
moon.
moons
Yeah.
of Saturn. It discovered that there was water ice in one of its massive plumes coming off of it.
What's a plume?
So it would be materials being ejected from the surface into space.
So a volcano
I'll have a picture up. You'll see kind of like a volcano, yeah.
could
but,
be a
but
plume.
I mean, yeah. I guess it would technically be a volcano, or it could be, but it's being shot up so high that it's going out into space.
Oh, okay. That's a big plume.
Yeah.
Although you have to, like, is there any atmosphere on Enceladus? Is there?
Well, there'd be no. Yeah. There's no atmosphere, and mostly because the gravity would be so low, it would be very easy to get something off the surface. But that led us to learn about the subsurface oceans on Enceladus, and it led us to start thinking that these moons and on these giant planets could be harboring life too, or could at least have the potential to be habitable. So,
Yeah.
that
That's
goes with
good. We got to put people somewhere.
that goes with Titan too. We learned that it's very, very chemically active. It has like all the chemicals that you need for life, basically.
So what does the grand finale mean? That just sounds like something kind of epic. What does it mean? It's
So
gonna do?
grand finale is just the fancy name that NASA gave this, I guess, final mission, you could call it. So they rearranged the orbit, and it was going to take, I believe, 45 more orbits around Saturn, and then finally plunge into its atmosphere, which it will be doing on the 15th. So tomorrow, if you're listening to this
When
at
it comes out.
release, yeah. Or it's already happened.
Yeah.
But, the reason for doing that is Cassini was, after all this time, finally running out of fuel. So like the fuel that they used to maneuver it around and change its orbit and stuff. After running out of fuel, then they would just not be able to control it anymore, and who knows what would happen. Like, it would probably be in a stable orbit for a while, but
It would decay eventually.
hundreds years
Yeah.
from now, it eventually could crash land into one of the moons. And the fear is if there's life on there, or
The
we
potential
seed
for
life
life,
on
yeah.
it because of it. Either way, we didn't want it to crash into any of the moons, so we just turned it around into deorbit into Saturn and become part of the planet forever.
Why was there no worry about that? I don't know if you know that question, but why was there no worry about that for Huygens lander?
About like introducing life.
Yeah.
Well, I'd imagine they went through some kind of sterilization process, but even then, it's not going to be perfect. Like, that's the reason why we can't drive Curiosity too close to where we think water is on Mars, because
Gotcha.
Curiosity didn't go through that strong of one.
Gotcha.
And being 20 years ago, I doubt
They even thought about it, yeah.
right. I think another big thing would be just like we didn't know Titan was like that, and Enceladus was like that.
Oops.
Until, right, yeah. So it may be, who
Yeah.
knows? Maybe there's no life there now, but 10,000 years from now, when we're long gone, we are the reason why life evolved.
And then
from
they'll
that
have
planet.
problems pronouncing Huygens. Right on. Well, it's good to know that Cassini's mission, I'd call it a success, wouldn't you? I mean,
Oh, definitely.
especially
yeah.
with in 2010, they were like, yeah, we'll keep going for another 7 years.
Right.
So, like, that's got to be labeled a success. And, with that amount of success, you wonder what's next for what you've called the Saturnian system. What is next?
Well, actually, I don't think anything is currently planned for the Saturnian system right now.
Everything seems to be Mars right now, right?
Mars, the next outer planet mission NASA has planned is the Europa Clipper mission. It's going to launch in the 2020s. So that
sounds like a boat. It does, doesn't it? Like, it sounds like the name of a boat.
Yeah.
Like a yacht or something.
So the point of it is to investigate Jupiter's moon Europa, which is also a very strong candidate for
habitability.
Right.
Yeah.
So much so that I guess they've decided to put their money towards there versus like Titan or Enceladus.
Yeah. It's also closer.
Yeah.
I mean, relative to us, it's closer. Relative to the sun, it's closer, I guess. I don't know.
Right. When you get that far out, I don't know how much. I mean, it's all math then, right? Fuel is negligible at that point, I think, because it's
all
tiny
assists.
little thrust will move you thousands, millions of miles.
We've seen that in Kerbal. We know.
Yeah, right. But NASA did definitely use a lot of the stuff that they learned from this mission for the Europa Clipper mission. I'm sure they're taking precautions on it for not seeding life. You know. I think they were. I don't know if it was going to be with that mission or not, but they were going to like basically drop something down that would either drill into the surface or like heat through the surface of Europa, because it has a subsurface ocean too.
Yeah, I'd like to see a core sample from the European.
Right.
The European Peninsula. Here's a core sample.
But further in the future, I know there's always talk about sending similar missions out towards like Uranus and Neptune. The same things. There would be so much that we would discover from that we have no idea about right now, I imagine.
Yeah, like Neptune's spot isn't even a spot. It's like a blemish that exploded years ago, and they're still Neptune's still self-conscious about it. Don't look at my scar.
Well, look how much we learned from New Horizons and Pluto. Mm-hmm. We always just assumed Pluto was just a
desolate little
a big
rock.
Ice ball.
Yeah.
And
it's got a heart on it.
It does, yeah. Or a whale.
It was waiting to whale tail. It was waiting to see us. It put its best heart forward. I would be interested to see any and all data coming back from Saturn as this ends. Before we started this, I sent Adam a picture. Cassini sent us back a bunch of really, really cool pictures. There's one where, like we mentioned, the hexagonal storm at the top of Saturn, but there's one that very closely resembles the pale blue dot picture.
It does.
That Voyager took.
So the whole picture is Saturn backlit from the sun, basically.
Yeah.
So it shows all of the rings, even the newly discovered, like very outer rings that we just barely found out about.
But if you zoom in on that picture, you can see a shining blue little dot, and that's us.
So I mean,
that's us. That's home.
In that sense, everybody is in that picture.
Yep.
So
that ever was or ever will be.
Right. Yeah.
Which is weird.
I feel like we should end this now with the pale blue dot speech.
Sure. Every young couple in love. Imagine the rivers of blood. I wish I was as cool as Dr. Sagan. No one's ever going to be that cool.
Do. Yeah.
Maybe Neil deGrasse Tyson. Anyway, is there anything else we got on the Cassini mission before we say goodbye to it?
Oh, I think that was about it. Just kind of wanted to, give it an overview for what's
important.
going on.
It's
It's
cool
important. It's something that's happening. I'm sure a lot of people are probably going to hear about it on the news or something and then not really know
what's going on.
Yeah, not know what it was or that it's been going on for the last 20 years.
So if I'm not mistaken, this is our podcast catcher submission episode.
We should be on iTunes now.
Yeah, so if you heard this there, man, be sure to give us a review and a like. If you saw this on YouTube, please be sure to give us a subscribe over there, and be on the lookout for more of these types of episodes, as well as Science Night's regularly scheduled content.
Yeah, and if there's something you want to hear us talk about, or or we got something wrong or
That too,
something,
yeah.
definitely let us know. We will always take criticism.
Absolutely. But for this and for the rest of the Science Nights, we're going to say goodbye to you and to Cassini. Bye-bye.
Bye.